Yes, sorry for the delay. I think the video quality is now 1080p, right? Yes, sorry. We are having some technical problem. I don't know. I have updated the app that causes the problem. I updated the software. Now the video quality is 1080p, right? You can see the option of 1080p, right? Yes. So we'll start. I'm audible, right? Audible, right? Okay. So this is lecture number 12 of analytical geometry, and this is part 2 of spheres. So if you haven't watched the previous part on spheres, so go through that. We will continue the problems based on spheres, right? So we're going to do 4 more problems based on previous class, and then we're going to introduce a new concept based on spheres, and then we will do some problems based on that, right? Okay. So we'll move on to I think how many problems we have solved in the previous class. I think we have solved 8 problems in the previous class, right? Yes, we have solved 8 problems in the previous class, right? So we'll start with problem number 9. So we'll do 9, 10, 11, 12. So we'll do 4 more problems based on those topic, and then we will introduce a new concept, and then we will do some problems based on that. Okay. Problem number 9. Okay. So a plane passes through a fixed point P comma Q comma R, right? We have a plane and it passing through a point P comma Q comma R, right? P comma Q comma R. Now we have a plane that is passing through a point P comma Q comma R and cuts the axis and cuts the axis in A comma B, comma C respectively. So that the locus of center of sphere, the locus of center of the of sphere OABC is P by X, Q by Y plus R by Z is equal to 2. It's a very important problem, right? So a plane passing through a fixed point P comma Q comma R and cuts the axis in ABC respectively, right? So we have a plane that makes an intercept capital A, capital B, capital C, right? And it passing through a point P comma Q comma R. So it is passing through a point P comma Q comma R, right? Let us say the intercepts are A comma 0 comma 0. It can be A, B, C this also, right? You can choose any. This is 0 comma B comma 0 and this is 0 comma 0 comma C. Okay, usually we will write this as A, B, C, right? So we will change this. Let's say this is our x-axis and A is A comma 0 comma 0, B is 0 comma 0. So we have a plane and it is passing through a point P comma Q comma R, right? Okay. Show that the locus of center of sphere OABC. Now we need to form a sphere that passing through this OABC, right? So I'm inserting a sphere that touching A, B, C, and O. Now we need to show that the center of that sphere locus is P by X plus Q by Y plus R by Z is equal to 2, right? Now, a very easy problem. Let the equation of plane, let the equation of plane be X by A plus Y by B plus Z by C is equal to 1, right? This is the equation of plane intercept form. Now P comma it passing through a point P comma Q comma R. That means if I replace X by Z by P comma Q comma R, it will satisfy. So it passing through the point P comma Q comma R. We substitute here, we have P by A plus Q by B plus R by C is equal to 1. Call this as equation number 1. Now, what is the equation of sphere passing through origin and A comma 0 comma 0, 0 comma B comma 0, 0 comma 0 comma C? Very important, right? We have already solved this problem. What is the equation of sphere passing through 4 points? You have said that is very important, right? So equation of sphere passing through origin and the intercepts A comma 0 comma 0, 0 comma B comma 0, 0 comma 0 comma C. What is the equation of the sphere? This x square plus y square plus z square minus ax minus by minus cz is equal to 0. That is what the equation, right? X square. We already done this. That equation is given by x square plus y square plus z square minus ax minus by minus cz is equal to 0. See, if we substitute this point, we'll get d to be equal to 0. And if we substitute the remaining points, you will have UVW in terms of ABC, which we already did. This is the equation of sphere passing through these 4 points, right? Now, we need to show the locus of center of the sphere is this, right? Now, what is center? Now, what is center? Center is minus u minus v minus w, right? Now, what is center of the sphere? So, compare with general form. So, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is the equation of sphere, right? Now, compare this. So, you will have 2u is equal to minus a, 2v is equal to minus b and 2w is equal to minus c. So we have u to be minus a by 2, v to be minus b by 2, w to be minus c by 2. So what is center of the sphere? It is minus u minus v minus w. So minus u minus v minus w is a by 2, b by 2, c by 2. Right? So we have center. Let us say center is a locus which is x comma y comma z. Right? What is center? It is a by 2, b by 2, c by 2. So we have a by 2, b by 2, c by 2. So compare this, we will have x is equal to a by 2, y is equal to b by 2, z is equal to c by 2. We have a to be equal to 2x, b to be equal to 2y, c to be equal to 2z, and from 1 we have x by p by a plus q by b, p by a plus q by b plus r by c is 1. So a is 2x, b is 2y, c is 2z is equal to 1. So take 2 common, bring that to this side. So we have p by x plus q by y plus r by z is equal to 2. This is the locus of center of the sphere, right? So very easy problem. Only thing is you need to find the equation of sphere passing through these 4 points, which you already know, which you already in the previous class. So a plane is passing through a fixed point p comma q comma r and cuts the axis in a comma b comma c. So we need to show that the locus of center of the sphere, right? Center of the sphere. The sphere is passing through this origin and ABC. Now, depending upon the value of p comma q comma r, the center will change, right? So that is given by p by x plus q by y plus r by z is equal to 2. Is it clear? So we are writing the equation of plane and passing through this point. Now equation of sphere is we know. Now center, let us say center is x comma y comma z and center is minus u minus v minus w. So equate that x comma y comma z to be minus u minus v minus w. So find ABC and replace that. Okay. We'll move on to problem number 10. So find the equation of sphere. Find the equation of sphere. Circumscribing the tetrahedron whose faces are very important problem. Y by b plus z by c is equal to 0. Z by c plus x by a equal to 0. X by a plus y by b equal to 0. X by a plus y by b plus z by c is equal to 1. To find the equation of sphere circumscribing the tetrahedron whose faces are. So they have given the 4 faces. So we need to, everything is clear, right? Audio and video. Okay, so we need to find the equation of sphere that is circumscribing the tetrahedron. They have given 4 faces of tetrahedron. See, first we need to find the vertices, right? Find the vertices. So we have a tetrahedron, right? Sorry. This is a tetrahedron. So they have given the four faces, right? So 1, 2, 3, and backside is 4. So they have given the four faces, right? So you can see 1, 2, 3, and 4. So first, what we need to do is we need to find these points, right? So I'm going to find the vertex of these 4 points. After finding these 4 points, you can easily find the equation of sphere that is passing through these 4 points, right? First, what I'm going to do is my aim is to find the vertex coord- coordinates of these 4 points. After that, we can find a sphere that is circumscribing this tetrahedron. Right. So after finding these 4 points, problem is very easy. Equation of sphere passing through 4 points that we can easily do. So our aim is to find the vertex of these four vertex, right? So what I'm going to do is to find the vertex, I'm going to solve these equations. I'm going to solve these equations. Um, I'm going to take, we have four faces, right? We have four faces. I'm going to take three faces at a time and I'm going to solve. I'm going to take three faces at a time. I'm going to solve, right? How I'm going to solve this? Let us take this and first two. Let us take this and these two. Let us take this and these two. So that you will have three vertex. Let us take these three so that you will have four vertex. Only thing is we need to solve, right? Okay, so to find first vertex, uh, take three faces at a time, and solve. So first I'm going to fix that face. I'm going to fix that face x by a plus y by b plus z by c is equal to 1. I'm going to take the first two face y by b plus z by c is equal to 0, z by c plus x by a is equal to 0. Now solve this equation to get the value of x by z. This is a non-homogeneous system of linear equations, right? And similarly, to find second vertex, instead of taking first two here, I'm going to take these two. And for third vertex, I'm going to take this and the last, right? Okay, so this is the first vertex. Solve. You can take any three face and solve. For finding first vertex, I'm taking this face and these two. Now this is a non-homogeneous system of linear equation. Now solve this using Gaussian method. You can see what is the coefficient matrix. 1 by A, 1 by B, 1 by C, and here there is no x. Y is 1 by B, Z is 1 by C, and here x is 1 by A, Y is 0, Z is 1 by C. This is augmented matrix, right? I'm doing directly because you know how to solve. This is 1, 0, 0. Here the unknowns are x, y, z. Unknowns are x, y, z. Now reduce this to row echelon form. So make use of R3 is transformed to R3 minus R1. This is equivalent to 1 by A, 1 by B, 1 by C, 1, 0, 1 by B, 1 by C, 0. So R3 minus R1. So 1 by A minus 1 by A minus 1 by B, 1 by C minus 1 by C, 0 minus 1. Now make use of the operation R3 is transformed to R3 plus R2, right? R3 plus R2. So this is equivalent to 1 by A, 1 by B, 1 by C, 0, 1 by B, 1 by C. Now if I add this 0, 0, right? 0, 0, 1 by C minus 1. Now this is in row echelon form, right? This is in row echelon form. So I'm just adding this. Now this is in row echelon form. Now you have to write this again in AX equal to B form. So when you solve this, you will have Z by C is equal to minus 1, right? So you have to convert this to AX equal to B form. So we have 1 by A, 1 by B, 1 by C, 0, 1 by B, 1 by C, 0, 0, 1 by C, X, Y, Z equal to 0, 0, minus 1, right? 0, 0, minus 1. Now you will have z by c is equal to minus 1. Solve by backward substitution. So you will have z to be equal to minus c, and you will have y by b plus z by c is 0. So z is minus c, z is minus c. So c will get cancelled. So you will have y by b is equal to 1. This implies y is b. So from first we have x by a plus y by b plus z by c equal to 0. See, y is b, so this will be 1. Z is minus c, this will be minus 1, right? This is 1. This is 1, right? 1 by a, 1 by c. So y is b, so b will be 1, z is minus c. So minus c, this will be minus 1, this will be 0. So you will have x is equal to a. So a comma b comma minus c is one of the vertex, right? So one of the vertex is a comma b comma minus c. Now you have to do this similarly. You need to find the other 4 vertex, right? Now the second vertex is you need to solve. Now for finding second vertex, take the face, fix this face x by a plus y by b plus z by c is equal to 1. So instead of taking first two, I'm taking second and third. So z by c plus x by a, z by c plus x by a equal to 0, x by a plus y by b, x by a plus y by b is equal to 0. Now you need to solve again for x comma y comma z. You can find the second vertex. You can find the second vertex, and similarly, I'm not going to do this. You will have the vertex to be a comma minus b comma c, right? Solve. Now for third vertex, so take these 3 equations: x by a, y by b plus z by c is equal to 1. I'm going to take this and this. X by a plus y by b is 0. X by a plus y by b is 0. Y by b plus z by c is equal to 0. So you will have vertex to be minus a comma b comma c, right? So this one vertex, the other vertex is a comma minus b comma c. This vertex is minus a comma b comma c. You need to find one more vertex. I'm going to find that vertex by solving these 3, right? So for finding a fourth vertex, I'm going to solve the first 3 equations: y by b plus z by c, y by b plus z by c is 0, z by c plus x by a, z by c plus x by a is 0, and x by a plus y by b, y by b is 0. See, this is a homogeneous system. This is a homogeneous system, and you can see determinant is not equal to 0. That means it has only trivial solution. See, all are very simple, right? If you understand linear algebra, this is a homogeneous system because you can see the output vector is 0 vector. But this is non-homogeneous because we have 1 0 0 1 0 0, right? This is a homogeneous system. This is a homogeneous system because we have Ax equal to 0. And if the determinant of quotient matrix is not equal to 0, means you will have only trivial solution. You can check the determinant of this. Determinant will be non-zero. That means only trivial solution. That means x is 0, y is 0, z is 0. Right? So therefore, what we actually need to find is, we need to find equation of sphere. We need to find equation of sphere passing through passing through a comma b comma minus c, a comma minus b comma c, minus a comma b comma c, and origin. That's it. This is the question that it is reduced to, right? So when we look at this problem, it seems to be very complicating. Only thing is we need to solve these 4 phases to find the vertex of all these 4. we will have, yeah, first vertex I have did using Gaussian method. Similarly, you need to do for finding second and third vertex also, right? So our aim is to find equation of sphere that passing through these 4 points, right? Now let us say, let the equation of sphere be, let us assume, let let the sphere be, let the sphere be, very simple now on, right? Equation of sphere passing through 4 points. Assume a sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Now find UVWD in terms of ABC, because it is passing through these in terms of ABC, right? Now it passing through origin. That means D has to be 0, right? Now first is it passes through origin. So 0 comma 0 comma 0. So that means D has to be 0, right? Because 0 plus 0 plus 0 plus 0. This implies D is 0. So D will be vanished. Now you need to find UVW in terms of A. It passing through A comma B comma minus C. It passes through A comma B comma minus C. So we will have A square plus B square plus C square plus 2UA 2BB minus 2WC equal to 0. So we have 2UA 2BB minus 2WC minus 2WC is equal to minus of A square plus B square plus C square. Right? Let us call this as equation number 1. Now similarly it passes through A comma minus B comma C, right? So what you will have is, so you will have 2UA, here Y is minus B, so 2BB plus 2WC is equal to minus of A square plus B square plus C square. Call this as 2. Now again it passes through minus A comma B comma C. So you will have minus 2UA plus 2BB plus 2WC is equal to, see, you will have only A square B square C square because it is square here. You will have minus of A square plus B square plus C square. Now we need to solve 1, 2, 3. That is, we need to find U, right? So solve for UVW in terms of ABC. So solve for UVW, right? Here the unknown is UVW. So solve 1, 2, and 3. So find the augmented matrix A comma B. So I'm solving for UVW, right? I'm solving for UVW. Is it clear up to now, right? So 2A, 2B minus 2C, 2A, 2B minus 2C. Here we will have 2A. This is what we have the quotient matrix, right? 2A, 2B minus 2C, 2A minus 2B, 2C, minus 2A, 2B, 2C, and here everything is minus A square plus B square plus C square. Now we need to reduce this lower Elan form. So make use of the operation R2 is transformed to R2 minus R1. R3 is transformed to R3 plus R1, right? So if you do this, you will have 2A, 2B minus 2C minus of A square plus B square plus C square. So 2a minus 2a minus 2b minus 2b. So we will have minus 4b. 2c minus half minus 2c. We will have 4c minus a square plus b square plus c square plus this will be 0, right? So minus of this minus of this will be plus. So minus plus will be 0. And R3 plus R1, R3 plus R1, R3 plus R1, right? R3 plus R1. Now if plus this, you will have minus 2 times a square plus b square plus c square, right? Now we'll make use of R3 is transformed to R3 plus R2, so that 4b minus 4b will be 0. So we will have 2a, 2b minus 2c. So minus of a square plus b square plus c square. 0 minus 4b 4c 0. So 0 0 4c, right? I'm adding this 0 0 4c minus 2 times a square plus b square plus c square. Now solve by backward substitution. This is in row echelon form. This is in row echelon form. We are solving for UVW. We are solving for UVW. So we will have 4CW, right? Because this is UVW. So 4CW is equal to minus 2 times a square plus b square plus c square. So 2 ones are 2s are. Let us find 2W, right? So 2W is minus of a square plus c square plus c square by 2. Because I can directly, instead of 2W, I can write that. Or you can write W is equal to something and I can cancel this. So we have found W in terms of a square, b square, ABC. Now solve this equation. Now solve this equation, you will have minus 4b UVW. So V plus 4CW is equal to 0. So let us keep this 4. So we will have, we need to find V, right? Okay. So we will have PV is equal to CW, right? And we know what is W, and we know what is W. Okay, let us multiply 2. Now instead of 2W, I will write minus half a square plus b square plus c square divided by this. Sorry, just a minute. It is 2c, right? W is 2W will be, sorry, it is C, not 2, because we will have 2W. C, I have to bring this side, right? Okay. So 2W is, this is C. Is it clear, right? C. I'm just multiplying 2. So we will have 2BB is equal to, and instead of 2W, I'm writing this as minus of A square, B square, C square by C. CC will get cancelled. So we will have 2 times B. 2 times B is minus of A square plus B square plus C square divided by B. So you can see some pattern. If you have W, we have C. If I have B, I will have B. And similarly, you solve for U. So we have 2AU, 2BB minus 2CW is equal to minus of A square plus B square plus C square. Now you know what is 2B, you know what is 2W. Substitute back here. You will have 2W to be equal to minus of A square plus B square plus C square divided by A. This is what you will have, right? See, you know 2B, you know 2W. Substitute back here. Find the value of 2A, right? Find the value of, find the value of 2U. So that's it. So therefore, equation of sphere is given by, equation of sphere is given by x square plus y square plus z square plus 2ux plus 2vy plus 2wz equal to 0, because d is 0. Now instead of 2u, 2v, 2w, replace these values, you will get the required answer. So we will have x square plus y square plus z square. So instead of 2u, I'm writing minus of a square plus b square plus c square divided by a into x minus of a square plus b square plus c square divided by b into y minus of a square plus b square plus c square divided by c into z equal to 0. So this is the required equation of sphere that is passing through these 4 points, right? Uh, this is a long problem, but easy problem only, right? So in exam point of view also, what you can do is you just show that you just find only one vertex by taking by solving this and these two. You will have a, b, and minus e. You just put similarly solving the other three phases. You will have these points a minus bc minus a bc and origin. Now it turns out to be equation of sphere passing through the 4 points. Now very simple. It is same as the previous one that we will do that we have done, right? Is it clear? Okay. So we'll move on to next problem. So problem 11 and problem 12. After that, we'll be moving on to very interesting concept. Very interesting concept in sphere. So find the equation of sphere. Find the equation of sphere with the center 2 comma 3 comma minus 4 and touching the plane and touching the plane 2x plus 6y minus 3z plus 15 is equal to 0. So we need to find the equation of sphere. That center has to be 2, 3 and minus 4 and it has to touch the plane. See, for finding equation of sphere, we should, if I know center and radius, I can find the equation of sphere in central form, right? X minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. We already know the center. Only thing is if I find radius, the problem is very easy, right? If I find radius, the problem will be very easy. Now, how to find radius? How to find radius? Think about it. So we need to find the equation of sphere. So we need to find the equation of the sphere with the center. So this as a center 2 comma 3 comma minus 4 and it touching the plane. It touches the plane, this plane, right? So it is touching this plane, right? What is this plane? It is 2x plus 6y minus 3z plus 15 equal to 0. See how to find radius. How to find radius? I'm waiting for your comment. This sphere is touching this plane. If I know center and radius, if I know center and radius, I can find the equation of sphere in central form. We know center here. How to find radius? You just have to recall everything before getting into the class, right? If you have recalled all the previous class, then this is very easy to answer. I want everyone to be answer. See, just visualize this. How to find radius? See, yes, perpendicular distance. That's it, right? See, don't mistake me. When you are getting into all the classes, you have to revise all the concept and come. Then only you can follow all the things because this is analytical geometry. Everything is based on previous topics, that is planes, lines, DC, DR. So without recalling and coming back this class, this will not going to be very helpful for you, right? You have to recall everything before getting into today's class. Okay. See, radius is nothing but the perpendicular distance from this point to the plane. That's it. The radius is nothing but, because it is touching the plane only, right? So radius is nothing but the perpendicular distance from the point 2 comma 3 comma minus 4 to the plane. So what is the perpendicular distance? What is the perpendicular distance from point to the plane? So it is nothing but modulus of ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This is the formula for perpendicular distance from any point to the plane. So here x1, y1, z1 is 2, 3 and minus 4, and the plane is, so we will have 2x1 plus 6y1 minus 3z1 plus 15 divided by root of 4 plus 36 plus 9. So here x1, y1, z1 is 2 into 2, 6 into 3, so 2 2s are 4. This is 18 plus 12 is 30, 45, 49 by 7. This will be 7. This root 49 is 7. 6 3s are 18. 18 plus 12 is 30. 30 plus 15 is 45. 45 plus 4 is 49. 49 by 7 is 7. So we have radius to be equal to 7. What is the equation of sphere? So it is x minus a whole square, y minus b whole square, z minus b whole square is equal to r square. The center is, this is the equation of sphere in central form. If you expand this, you can get in general form. Find the equation of sphere, passes through the point. find the equation of sphere that passing through these 3 points and it has to touches the plane. So let us assume the equation of sphere to be let the equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So we need to find the values of u, v, w and d. Now it passes through these 3 points. So you will have three system of equations. So it passes through 4 comma 1 comma 0. It passes through 4 comma 1 comma 0. So you will have 4 square is 16. So 16 plus 1 plus 0. 2u into 4. 2v into 1. This will be 0 plus z is 0. So you will have 8u plus 2v plus d equal to minus 17. Call this as 1. Right? Call this as a. Now again it passes through 2 comma minus 3 comma 4. So 2 square plus 3 square plus 4 square 2ux 2vy plus 2wz plus d equal to 0. So 4u minus 6v plus 8w plus d equal to 16 plus 4 is 20. So we have minus 29. Call this as right. Call this as 2. So we have 4u 8u plus 2v plus d is equal to minus 17. 4u minus 6v is. Now again it passes through 1 comma 0 comma 0. So we will have 1 plus 0 plus 0. 2u into 1 this is 0, this is 0 plus d equal to 0. So you will have 2u plus d is equal to minus 1, right? 2u plus d is equal to minus 1. Okay. So this is number 3. So from this I can write 2u is equal to minus 1 minus d. So u is minus 1 minus d divided by 2. Right. So what I'm doing is, okay, let us keep this as it is. Now it has to touch this plane. Right. So we need to find an equation of sphere that has to pass through these 3 points and also it has to touch this plane. That means the radius will be equal to the perpendicular distance, right? What is center? Center is minus u minus v minus w. Yes or no? Because we have assumed this to be the equation of sphere. We don't know what is center. For this center is minus u minus v minus w. Right? What is the plane? Plane is this is the fourth constraint. Already we have three constraints. It has to pass through these 3 points. The fourth equation is going to be radius has to be equal to this perpendicular distance. Right? So that means radius has to be equal to the perpendicular distance. So 2x1 plus 2y1 minus z1 minus 11. 2x1 plus 2y1 minus z1 minus 11 divided by root of 4 plus 4 plus 1. So radius has to be this. Now what is x1 y1 z1 is minus u minus v minus w minus 11 divided by t. So radius has to be this. Now what is radius? Radius is root of u square plus v square plus w square minus t. This is the radius formula, right? So bring this 3 to this side. We will have minus 2u minus t 2v minus w is equal to 0. Right? So we have this has to be the fourth equation. Now we need to solve 1, 2, 3, 4, right? Now what I'm going to do is from here we know what is du. I'm going to convert everything in terms of d, right? Everything in terms of d. We already know u in terms of d. From this we can find v in terms of d, right? Because we know u in terms of d. Substitute this u here, so we can find v in terms of d. I'm not going to do that. So substitute this u here, right? Substitute this u here. We can find v in terms of d, right? Because u will be in terms of d. Already we have d here, so we can find v in terms of d. So you will have v to be equal to. So you will have. So already we have u is minus 1 minus v divided by 2. You will have v to be equal to 3d minus 13 divided by 2. See, very simple only. Just have to substitute this u here. So you will have v in terms of d. You will have v to be 3d minus 13. And you know u in terms of d. And you know v in terms of d. So you can find w also in terms of d. So you will have w to be equal to 5d minus 33 divided by 4. Let us call this as some star, right? Now you know UVW in terms of D. Now substitute here. Now substitute here. Substitute here. That's it. If you don't want square root, you can square it on both sides, right? You can square it on both sides. You will have 9 times u square plus b square plus w square minus d. It's a lengthy problem. Minus 2u minus 2v plus w minus 11 whole square. Now substitute u v w in terms of d. We already know the values of u v w in terms of d. Now substitute back here. So everything will be in terms of d. Everything will be in terms of d, right? Everything will be in terms of d. So everything will be in terms of d. So solve for d. We will have d to be equal to 5. See, you know UVW in terms of D. UVW, everything convert to D. Now solve for D, everything will be in D. Solve for D, you will get D to be equal to 5. So since you know D, you can also find UVW, right? Substitute in star, you will get U to be minus 3, V to be 1, W to be equal to minus 2. Therefore, the equation of sphere is x square plus y square plus z square minus 6x plus 2y minus 4z plus y is equal. This is the equation of sphere that has to pass through these 3 points and also it touching the plane, right? So you just have to this involves some lengthy calculation, but you have to practice. So next, in exam point of view, if this question comes, just remember the value of d. D is 5. You know D is 5. You can find UVW, right? Is there any doubt up to now? So we will have a 2 minutes break. We're going to move on to the new topic in sphere. So we'll have a 2 minutes break and then we'll move on to the new topic in spheres. So yes, so we'll move on to next concept in sphere, which is called plane section of a sphere. Plane section of a sphere. So I'm going to write down 3 notes. Based on that, we're going to do many problems, right? Only thing is you have to understand this slide. That's it. So what I'm going to do is we have a plane. Sorry, we have a sphere. I'm going to cut that by a plane, right? We have a sphere. I'm going to cut that by a plane. Section means we're going to cut, right? So we have a sphere. I'm going to section it by a plane. So we will have a new figure. We will have a circle, right? So if you have a sphere and if you section it by a plane, right, you just open the cutted part, you will have a circle. So what is the equation of circle in 3D? That is what we're going to do now, right? So for circle in 3D, see, first is the section of a sphere. The section of a sphere, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 by a plane ax plus by plus cz plus d is equal to 0 is a circle, right? Is a circle, and to find center and radius of this circle. This is what the first set of problem will be. So we will be having a sphere, and then we're going to cut it by a plane. We will be having a circle. For that circle, we're going to find center and radius. I'm going to do that with the help of problem, right? I'm going to do this with the help of problem. See, we have a circle. Sorry, we have a sphere, right? We have a sphere. Right, so we have a sphere. I'm going to section it by a plane, right? I'm going to section it by a plane. So the image, this part, right? This is a circle that it will form. Visible. This is a circle, right? So it will form a circle if we section it by a plane, right? So we have a plane. Right? So if I have a sphere and if I section it by a plane, the image will be a circle, right? That is red color is a circle, right? Red color is circle. Now we how to also we going to find the what is the center and radius of this circle. right? We're going to find this thing also. This is the center. Radius, right? This is the center of sphere. This is the center of sphere. This is center of circle, right? Let us call this as C1 and C to be the center of sphere and C1 is the center of circle, right? And this is capital R and capital R is the radius of sphere, right? Because if I connect any point from C to R, you will have radius of sphere, right? So we have, let us assume this to be P, right? So let C be the center of sphere, C1 be the center of circle, right? C1 be the center of circle. Let small r be the radius of circle. Let let capital R be the radius of sphere and small r be the radius of circle, right? So what we're going to do is how to find center and radius. That is the next question. So we're going to do this with help of problem. So that means whenever you have a sphere and a plane, that is a circle, right? Whenever you have an equation combined with a sphere and a plane, that will be the circle. Very important, right? So whenever you have a sphere and a plane combined, that will be the circle equation. That will be the circle equation, right? Because we know sphere and a plane will give you a circle, right? So that means the equation of circle in 3D is a sphere combined with plane. What is the equation of circle in a 3D? A sphere combined with a plane, right? How to find the center of this circle and how to find radius of this circle, that we will do with the help of problem. As of now, just remember only this, right? We are also going to find center and radius of circle, but I'll tell you the help of problem. As of now, just remember this. Now second notice second notice second notice sphere passing through a given circle. Equation of sphere passing through a given circle. Equation of sphere passing through a given circle, right? See, they will give circle but not in 2D. They will give a circle equation as a sphere and a plane, right? So let the equation of circle be uh, let the equation of circle be, so they will give a sphere. Let us say sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, and they will give a plane also. They will give a plane also. Ax plus by plus cz plus d equal to 0. This is the equation of circle, right? Because for equation of circle, sphere and a plane should be there. That is s is equal to 0, comma p equal to 0. So we are going to find an equation of sphere passing through a given circle. Passing through a given circle. That means we need to find an equation of sphere that has to pass through this circle. I think there is some See, what we're going to do is we're going to find an equation of circle. See, what is this circle? So we have a sphere. This is the circle, right? This is the circle. How this circle? So we are sectioning it by a plane, right? We are sectioning it by this plane. Right? So we're going to find an equation of sphere that has to pass through this circle. So that has to pass through this circle. So we are finding an equation of sphere passing through a given circle. So you can see this is a circle. So green is the equation of sphere that passing through a given circle. So the equation of that green sphere is given by s plus lambda p equal to 0. So equation of sphere passing through a given circle. For a circle, we should have sphere and a plane. This lambda can be found by suitable simplifications, right? So we are going to find this sphere. We are going to find this equation of sphere passing through a given circle. Is it clear up to now? It's a very important concept. Whenever we are sectioning a sphere by a plane, the nu will be a circle. So equation of circle will be s is equal to 0, comma p equal to 0. So you will have a sphere and a plane. Now second is equation of sphere passing through given circle is given by s plus lambda p equal to 0. Very important. S plus lambda p equal to 0. Now third is sphere passing through intersection of two spheres. Equation of sphere passing through the intersection of two spheres is given by s1 plus lambda s2. So if you want to find an equation of sphere that has to pass through the intersection of two spheres, that is given by s1 plus lambda s2 is equal to 0. This is very easy, right? So two sphere you will have some intersection. You need to find one more sphere that has to pass through the intersection of the two spheres. That is given by s1 plus lambda s2 is equal to 0. If you understand these three note, then every problem will be easy. So based on this three note, we're going to do many problems. This is the second topic in sphere. The first topic in sphere is basic idea, general form, passing through 3 points, 4 points, and so on. The second topic is plane section of a sphere. So we are sectioning a sphere by a plane. We'll do problems, right? See, it will be based on, they will give a sphere and a plane. That means it has to be a circle. For that circle, you need to find center and radius. That means you need to find C1 and small r. C1 and small r, right? Okay, so we'll do some problems based on problem number 1. x square plus y square plus z square minus 8x plus 4y we need to find the center and the radius of the circle. So for circle, they will give a sphere and a plane, right? So they have given sphere and they have also given the plane. So we need to find the center and radius of that. Okay, so we need to find the center and radius of this circle. So we'll find the center and radius of circle. So they are given the equation of sphere, right? So they are given the equation of sphere, which is x square plus y square plus z square minus 8x plus 4y minus 8z minus 45 is equal to 0. Now let us find the center and radius of this sphere. So what is the center and radius of this sphere? So compare with general form. Compare with general form. So x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus t equal to 0. So you will have 2u is equal to minus 8, 2v is equal to 4, 2w is equal to 8. So u is minus 4, v is 2, w is 4. Center is minus u minus v minus w. So 4 comma minus 2 comma minus 4. This is the center of sphere. And what is the radius of sphere? The center of sphere is 4 minus 2 minus 4. And what about the radius of sphere? We have assumed it is to be capital R. So root of u square plus v square plus w square minus t. So u square plus v square plus w square minus d. So it will be plus 45. Because d is minus 45, so minus is plus 45. So this will be root of 32, 36, 36 plus 45. 36 plus 45 will be 36, 45. 81 is 9, right? Okay. As of now, we know the center and radius of the sphere. See, we have a circle. We should find the center of a circle, which which is this, right? So we need to find the center of this circle, which is C1, right? C1, and also we should find the radius, which is small r. How we got this? We have got this by a plane section. Right? Okay. So they are given yes, they were given D. Okay. Now we already know the center of the sphere, which is capital C. Right? What is that? That is 4 comma minus 2 comma minus 4. And also we know the radius of sphere, which is capital R, which is 9. Now we need to find C1. We need to find C1 and small r. C1 is the center of circle and small r is the radius of circle. So how to find C1 and how to find R? See, we can easily find radius easily by Pythagoras theorem. Yes or no? We can easily find radius by Pythagoras theorem. See, this distance is P, right? What is P? P is nothing but the length of the perpendicular from this point to the plane. Yes or no? So we know equation of plane, which is x minus 2y, which is x minus 2y plus 2z minus 3 equal to 0. So you just find the length of the perpendicular. You have already done this, right? From this point to the plane, that will give you P. You already know capital R. So find small r by Pythagoras theorem. So you can easily find the radius, right? So you can find P. P is the perpendicular distance from that point to the plane. By Pythagoras theorem, you can find radius very easily. Now, how to find the center? How to find the center, right? That is how to find this C1 point. How to find C1 point, right? Okay. How to find C1? How to find C1? See, I'm going to write the equation of CC1. So what is this equation of this line? What is the equation of line? So what is equation of CC1? What is the equation of line in symmetrical form? X minus x1. See, this line is passing through this point. So x minus 4 divided by a. This ABC is the direction ratio of the line, right? X minus 4 by a, y plus 2 by b, z plus 4 by c. This is the equation of this straight line CC1 in symmetrical form. So to find equation of line in symmetrical form, we should know any one point and we should know the direction ratio, right? Okay. So where a comma b comma c, where a comma b comma c is direction ratio, right? Now you can see what is the direction ratio of normal to the plane. What is the direction ratio of normal to the plane? This is the direction ratio of normal to the plane. Yes or no? This is the plane. We have this is the plane we have, right? So we need to find this circle radius. Now, what is the direction ratio of normal to the plane? So it is 1 minus 2, 1 minus 2, 2. Yes or no? Now we can see these two lines are parallel. Yes or no? Direction ratio, that is, we need to find the equation of CC1, right? Okay. See, very important problem. Just understand this concept, right? Just understand this concept. Before that, what we will do is, before that, what we will do is, let us say it is equal to some k. So that means we will have, okay, what we will do is, okay, let us say it is equal to some k. Now, what is direction ratio of normal? Direction ratio of normal of the plane is parallel to the line CC1. Yes or no? These two are parallel. So if two lines are parallel, the corresponding direction ratios are proportional. We know, right? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Now, what is direction ratio of normal? It is 1 minus 2, 1 minus 2, 2. And what is direction ratio of the line? It is A comma B comma C. So since they are parallel, this implies A by 1 has to be B by minus 2. This has to be C by minus 2. This implies A is 1, B is minus 2, C is minus 2. So we have found the direction ratio of CC1. Is it clear up to now? See, you can equate to some k and take that k outside. One of the direction ratio is 1 minus 2 minus 2. Any number proportional to that is also direction ratio. So to find equation of CC1, right? To find equation of CC1, ABC is the direction ratio of CC1. CC1. We don't know direction ratio of CC1, but we know direction ratio of normal to the plane, and they are parallel. That means equation of CC1 is, so therefore equation of CC1 is given by x minus 4, x minus 4 by 1, y plus 2 by minus 2 is equal to z plus 4 by minus 2. So this is the equation of the line CC1. Now let us find any point on this line will be of the form, right? Any point on this line will be of the form. So x is so any point on the line will be of the form. So x is k plus 4, y is minus 2k minus 2, z is minus 2k minus 4. So that means for some k, C1 will be equal to this, yes or no? For some k, C1 will be equal to C1 will take that value for some k, because we know any point on this coordinate, sorry, any point on this line, right? Any point on this line will be of that form. What form? K plus 4 minus 2k plus 2 minus 2k minus 4. So depending upon the value of k, you get all the points. For some k, it will be equal to C1. Now remember, C1 lies in the plane. Yes or no? C1 lies in the plane, right? C1 lies on the plane. What is the plane they have given? X minus 2y, x minus 2y minus 2z, sorry, plus 2z plus 2z minus 3. Yes or no? The C1 point lies in this plane. So that means that you substitute that coordinate here, right? You substitute that coordinate here. So you will have k plus 4 minus 2 times y plus 2 times z minus 3 is 0. So k plus 4 plus 4k plus 4 minus 4k minus 8 minus 3 is 0. So 4 plus 4 is 8, 8 minus 8 is 0. This implies k is 3. So when k is 3, C1 will take that coordinate. C1 will take that coordinate, right? Sorry. 1 minus 2 plus 2, right? The direction ratio of normal to the plane is 1 minus 2, 2. Then 1 minus 2 plus 2. So C is plus 2. Or no? So direction ratio of plane is 1 minus 2, 2. So A by 1, B by minus 2, C by 2. We have C to be equal to plus 2. Sorry. We have C to be equal to plus 2. Plus 2k. Have plus 4k. So 4k, 8k. So you will have 9k. 4 plus 4 is 8. 8 minus 8 is 0. So you will have minus 3 is 0. So 9k is equal to 3. So you will have k to be 1 by 3. So if k is 1 by 3, center point will be, so therefore C1 point is, C1 is the center of circle that we need to find. So k plus 4 minus 2k minus 2, 2k minus 4. So k plus 4. So 1 by 3 plus 4 by 3 minus 7 by 3 minus 9 by 3 minus 10 by 3. This is the center of the circle, right? This is the center of circle. Sorry, 13 by 3. So these are 12, 12 is 13. So 13 by 3 minus 8 by 3 minus 10 by 3. This is the center of the circle, right? So very simple, very important idea. So how to find the center of a circle, how that circle is formed is we are sectioning that sphere by a plane. So C1 is the point that we need to find. Radius we can find a Pythagoras theorem, or you can also find you can find P by distance formula also. So whatever you can do, if you found center, then you know two coordinates. You can use distance formula to find P also. But without knowing the center also, you can find P. P is the perpendicular distance of this point to the plane. You always use that idea, right? As of now, is it clear? So we have found the center of the circle. We have found the center of the circle. Okay, now we will find radius of the circle. Now to find radius, so to find radius of circle, so first we will find P. So P is the perpendicular distance from the point C, right? C is the center of sphere. 4 minus 2 minus 4 to the plane, right? So, no, to the plane. What is the plane? X minus 2y plus 2z. So just apply the perpendicular distance formula. So it is x1 minus 2y1 to z1 minus 3 divided by root of 1 plus 4 plus 4. X1 y1 z1 is will give you 1, right? This will give you 1. After this, you can apply Pythagoras theorem now. X1 1 minus 2. Is it clear, right? Right? Root of. Okay, we have P to be equal to 1. So we have P square plus R square is capital R square, right? The Pythagoras theorem. P square plus R square is capital R square by Pythagoras theorem. think we are not getting the answer. So we have P to be equal to 1, R is a radius. And what about capital R square? Capital R is a radius, which is 9. What mistake we have made? Yes, correct only. So R square is 81, right? That means R square is 80. R square is 80 is correct only. So R is root 80. So root 80 is the radius of that circle. So if we root 80 is same as 4 root 5, right? So that means we have found the small r. Small r is the radius of circle. Capital R is the radius of sphere. P is the perpendicular distance from that point to the plane, right? So using this idea, you can easily find the center and radius of this circle, right? So very interesting problem, very conceptual problem. So if you want to find center and radius of the circle, you have to follow this method from now on, right? So next class we will continue more problems based on this. So as of now, you remember if they give a sphere and a plane means that is this equation of circle, right? So for that circle, how to find center and radius? This is the method. To find to find center, first find equation of CC1 in symmetrical form. So one point you know that you can find from the center of sphere. So equation of CC1 is x minus 4 by a, y plus 2 by b, z minus z plus 4 by c, where ABC is the direction ratio of this line. Now what is direction ratio of normal to the plane? It is 1 minus 2. These two are parallel. So from this you can get the value of ABC. After that, any point on this coordinate will be of the form like this, and C1 lies in this plane. So substitute this coordinate in this plane. You can get the value of center. After finding center, you can find the point P using the distance formula between CC1, or I will recommend you to find the value of P by just finding the perpendicular distance of this plane to this point, right? Perpendicular distance of this P. This is the perpendicular distance of this plane to this point. So from this you can find P turns out to be 1. So we already know P, we already know capital R, we need to know small r. You can do that by Pythagoras theorem, right? So next class we will do more problems based on this. As of now, you remember that whenever they give sphere and a plane, that is circle, right? So next class we will do more problems, right? So thank you, all the best.